Hello and welcome back to my channel. So today let's learn about electricity. We all know what is electricity. Electricity has an important place in modern society. We use it in our homes, schools, hospitals, industries and many more places. To understand the topic of electric current and circuit, let's take an example of a torch. In a torch, we know that the cells or a battery, when placed in proper order, provides flow of charges or an electric current through the torch bulb to glow. We also have seen that the torch gives light only when its switch is on. So what does a switch do? A switch makes a conducting link between the cell and the bulb. A continuous and closed path of an electric current is called an electric circuit. Now, if the circuit is broken anywhere or the switch of the torch is turned off, the current stops flowing and the bulb does not glow. Electric current is expressed by the amount of charge flowing through a particular area in unit time. Or you can also say it as the rate of flow of electric charges. In circuits, using metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time when the phenomenon of electricity was first observed. So, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Conventionally, in an electric circuit, the direction of electric current is taken as opposite to the direction of the flow of electrons, which are negative charges. If a net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is I equal to Q divided by T. Here you can see a schematic diagram of an electric circuit comprising of an electric bulb, a cell, a battery, and a plug key which acts as a switch, and it contains an instrument called an ammeter which measures electric current in a circuit, and it is always connected in series in a circuit through which the current is to be measured. And note that the electric current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell through the bulb and ammeter. The SI unit of electric charge is coulomb, which is represented by the letter C, which is equivalent to the charge contained in nearly 6 into 10 to the power 18 electrons. And we know that an electron possesses a negative charge of 1.6 into 10 to the power minus 19 coulomb. The electric current is expressed by the unit called ampere, represented by the letter A, named after the French scientist André Marie Ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per second. That is, 1 ampere is equal to 1 coulomb divided by 1 second. Now let us solve a problem. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So the solution will be, it is given that current, that is represented by the letter I, is 0.5 ampere and time t is 10 minutes. We need to convert minutes into seconds first. So 10 minutes into 60 seconds, we get it as 600 seconds. So from the formula I equal to Q divided by T, we have to find Q. So by substituting the values given, we obtain Q, and the value is 300 coulomb. If you take two water tanks which have the same level of water, you can observe that there is no flow of water because both are at equal levels. Whereas if you take one tank with a higher pressure than the second tank, then you can see there is a flow of water. Similarly, for flow of charges in a conducting metallic wire, The gravity, of course, has no role to play. The electrons move only if there is a difference of electric pressure, called the potential difference along the conductor. Now, this difference of potential may be produced by a battery consisting of one or more electric cells. The chemical action within a cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charges in motion in the conductor and produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expend its chemical energy stored in it. The electric potential difference between 2 points in an electric circuit carrying some current is the work done to move a unit charge from one point to the other. So the formula is potential difference denoted by the letter V is equal to work done, that is W, divided by charge, that is Q. So V is equal to W divided by Q. The SI unit of electric potential difference is volt, denoted by capital V. It is named after Alessandro Volta, an Italian physicist, and 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. That is, 1 volt is equal to 1 joule divided by 1 coulomb. And the instrument used to measure the potential difference is called the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Let us solve a problem now. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt? It's very simple. It's clearly given the potential difference V is 12 volt and charge Q is 2 coulomb. So we must find the work done. So according to the formula, V is equal to W divided by Q. We get W is equal to V into Q. Substituting the values, 12 into 2 is equal to 24 joule. So that's the work done. As you have already seen, an electric circuit consists of a cell or a battery, a plug key, and electrical components and connecting wires. It is often convenient to draw a schematic diagram in which different components of the circuit are represented by the symbols conveniently used. So conventional symbols used to represent some of the most commonly used electrical components are If you have any doubts still here, you can comment below and do subscribe to my channel and keep watching for more videos. Thank you and have a good day.